Hello and welcome to SudoKanard. This puzzle here is one of the highest pointers in the qualifying round for Sudoku Championship, the German Sudoku Championship. It was created by young Indian author Nityant Agarwal, and it was quite tricky. So the rule of Little Killer Sudoku is that whenever you have a number with an arrow, then this number is the sum of all digits along the arrow. So those 4 digits have a sum of 8, those 7 digits have a sum of 44, etc. And the rest of the rules is just Sudoku rules. And there's this very nice theme of repeated totals. And let's start. So my attention is drawn towards those 4 cells with a sum of 6. It is really, really low for a sum of 6 digits. And you can see that if I try to put the minimum values, I get 5. So there's a degree of freedom, only 1 degree of freedom. One of those digits must be 1 more. And when I put 1 here and 2 there, I mean it could have been the other way around, but I'm just typing in options to see what the minimum is. But something interesting is this 6. This 6 must be 1 and 5 or 2 and 4. So it has to include a 1 or a 2. So it's impossible to have 1 and 2 here. So this just uses our degree of freedom. So the only option for those digits is 1 and 3 to use this degree of freedom, and the other 2 digits have to be 1. And those now have to be 2 and 4. Let's move on to this 7, and this 7 here, and we see that this has a minimum of 2, this has a minimum of 2, and those have a minimum of 1 and 2. And you see that this minimum option has a sum of 7, so it has to be the right digit. So this is a 2, this is a 2. It resolves this. This is 4 and 2, and now this 2 makes this a 2, this a 1, and it resolves the 3 and the 1. So let's have a look at this 8 now. 6, 7, 8. That only seems logical. This is a minimum of 2, this is a minimum of 2, this is a minimum of 2, and this is a minimum of 1. There again we have 1 degree of freedom. So one of those digits must be higher, but this couldn't go higher to make a 2. If I make this a 2, then this has to be at least 3, and the total is too big. So this one is confirmed. But this can't be a 2 actually, so the minimum is a 3, and so the minimum scenario makes this a sum of 8, so we have to put the digits like this. And now this 8 is fulfilled. Let's move on to 9. So the minimum value here is 1, here it's 2, here it's 1, here it's 1. That's 5. 5, so we have 4 degrees of freedom, which seem to be a lot. But then something interesting is happening, if I recall correctly. Oh, first there's something I've forgotten to address. This 7 sum without a 1 and a 2 has to be 3 and 4, and there are 3s and 4s in those columns, so we need a 3 and a 4 somewhere here. And corresponding in the same manner, this 8 doesn't use 1 and 2, so it has to be 3 and 5 this way. So that should be important. Is that it? I think that's it. Alright, so let's go back to our minimum and our options. So how can we What if this is not a 1? Well, if this is not a 1, then it has to be a 5, in which case we've used all 4 degrees of freedom. So this can only be a 1 or a 5. But if this is a 1, we still have to make 8 with those. And you see that this can't be 2 or 3. It could still be a 4. And if I put a 4, then this could still be a 3. I'm just wondering if this is really where I'm supposed to look. I think it is. Right now, I'm not sure. All right. So it could still be 1 here, 1 there. Yes, I think it could. And then 3 here and 4 there. But actually, I don't think it could. And I tell you what, if I try to make this a 3, this a 4, then how do we do this 9? This 9 will then have to use a small digit, will be, well, and this small digit should be 1 or 2. But 1 and 2 here and there forbid those 2 cells from being 1 or 2, so there would be no option to provide this 9. And you would tell me, and if this is 4, then this could be 2, and this could be 1. But no, because this would have to be a 2, which is not available. So 4 is not an option here. So the only other option other than 9, than 1, is 5. So this is 1 or 5. And 5 would use all the degrees of freedom. Then what if this is a 4? Then this could still be 3 with 1 and 1. But then again, this wouldn't be 1, 2, 3, 4. This wouldn't be 1, 2, 3, 4. And there would be no option for this 9. That is real sorcery. So this is 1 or 5. And then we could still have perhaps 1, 1, 1, and 6. So either there's a 5 here and 2 1s and there's a 2, or those are 3 1s and we get a 6 here. So that's a lot of options to ponder. But then if I make this a 6 and those 1s, what options do we have for this 9? Well, it couldn't use a 1 or a 2, because none of those is going to be 1 or 2. It couldn't be 3 and 6 because of the 6, and it couldn't be 4 and 5 because this cell can't be 4 or 5. So this option must be removed as well. This is a real 2. And we now know that 2 of those cells must have a 1, and the third one must have a 5. And let's look at what is available for the 9. Because there's a 1 in one of those, well, could this be a 1? I think this could still be a 1. Could this be a 3? Well, I think 1 here and 8 there is an option. Oh no, because 2 of those 3 digits are 1s. So at least one of them here is a 1, so this would never be a 1. Can't use a 2. It can't be 4 and 5 because this cell is a 4 and a 5, so it has to be 3 and 6. This is really a complicated puzzle. Actually, I think 112 is still underrated, but then maybe I've done something too complicated. I'm not sure. Now, I don't think I can find anything more about this. What about 2? There has to be a 2 here. There has to be a 2 here. Where is 1 in this box? Well, 1 can't be here because it would remove 1 from those 2 cells. There are still 3 places for 1, I think. Right. Where should I look next? Perhaps this 28. This 28 sums. What are the minimum values? This has a minimum of 4. This has a minimum of 4. This can't be a 1 because it sees both cells here, and one of them is a 1. So the minimum seems to be 3. This is not 1 for the reason I mentioned earlier. It's not 2 or 3, so the minimum is 4. Here the minimum is 3. Here the minimum is 4, and here the minimum is 5. Let's have a look at all those values. 5, 9, 12, 16, 19, 27. So I only have 1 degree of freedom with those values. And you see that if this increases, then this also has to increase. Or if I increase this by 1, then this has to increase by 1, and I have only 1 degree of freedom. And if I increase this by more than 1, then that's too much. So this is a 3. What about those? It's the same here. This has to be a 3. If I make it 1 bigger, then this has to be much bigger. And actually this can't be a 5, so this won't use a degree of freedom. This won't use a degree of freedom, so this won't use the degree of freedom. That's a 3. This here is not a 3. And I know there must be a 3 somewhere here. So can this use a degree of freedom? Perhaps. This being a 5 would be something big because it will make this and that once. So this must be, oh sorry, this I think must be 4, 5, this must be 5 or 6, this must be 4 or 5. Sorry. I'm not sure I can do more right now. But there seems to be something. So this is 4, 5. I think I remember there was something about this digit. What was that? I think this had to be a 4. Why couldn't this be a 5? Well, not sure. 5 here. Oh yes, I remember. I think I remember now. If this is a 5, then this is 1, this is 1. And now none of those can be a 1, so that's a 1. But that seems to work. And I don't remember why it would break. bobbins. I thought I remembered something like this. Oh, but there's something of interest is that this is a 4. I should do some Sudoku first. This is no more a 4. Oh, there's something with this too. Because of this 57. 57 is quite a large sum, and this 2 would probably not fit. Let's imagine this is a 2, and let's make all other values very big. So let's say this is 1, this is 9, this is 8, this is 9, this is 9, this is 9. Then I get 55. Yes, that's it, 55. So 2 wouldn't work here. So this is a 2. And this now is a 2, and that's it. That's it. There's a 1 here or there. Knowing this, if this is 1, then this has to be 5. And if this is 1, then this has to be 5. So this can't be a 5, that's a 4. And this can't be a 4, so that's a 4. And knowing that one of those has to be a 1, one of those has to be a 5, so this is a 1. That's really clever. That's so typical Nityant. And there's a 1 here or 1 there. And this 4 now has an impact on this 57. We saw that with a 2 here, the maximum value for this diagonal was 55. So what is now the maximum? If I make this a 9, this a 9, this an 8, let's say this a 9, this a 9, this a 9, that's 18, 22, 31, 31 plus 17, 48, 57. All right, so I need to put the maximum values to achieve a sum of 57. So this is a 9, and now this places the 3's. Those here must be an 8-9 pair. I get this 9 here. And now this 57 is resolved. Let's do some Sudoku. What digits can we place? Here this is 7 or 8. Those are 6, 7, and 8 in some order. And this or that must be a 6. Here I need 5, 6, and 7. Here 6, 7, or 8. Here 6, 7, or 8. This is 7, 8, or 9. And we still know there's a 5 somewhere here, but there doesn't seem to be a digit that I can place with certainty. Well, maybe I shouldn't rush on pencil marking. But there's something here. Knowing that this is a 4, now the sum of those two digits must be 10, so it must be 4 here, 6 there, or 5 in both places. Let's have a look at this 30. We already have 10 here. What are the minimum values elsewhere? This has a minimum of 5, here minimum of 5, minimum of 5, minimum of 5, which makes 20 plus 10, 30. So those are all 5s. That's splendid. So this is not 5, and now we know that 1 is here, 1 is there, 5 is there to achieve this sum of 9. This is a 1. This now is a 4, and this is a 6. The 28 sum is fulfilled. Only the 44 sum is not fulfilled yet. So now that's a 4. Do we have all 4s? I think we do. This is 7 or 8, so 9 in this column is here. That's not a 9. This is 7 or 8. This is a 9. This is 7 or 8. This is as well. 6, 7, 8 here. And that is a 5. This one here is not a 6. That's a 6. That's a... Sorry, something is going wrong. I don't know what. Sometimes something gets stuck on the pen part. This is not a 9. That is a 9. This is 8. This is 9. That's not 8. This is 7 or 8. So this now has to be a 6. 7, 8, lots of 7, 8 pairs. I need a 6 somewhere here. This now can only be a 9. I need a 5 here, it goes there. That's not a 5, that's a 5. This is 7 or 8. Oh, this 8 now. Makes this a 7, 8, 7, 7, 8. Oh, all those pairs are now resolving nicely. 7, 8. That's not 7. That's an 8. This is a 6. This here is a 6 as well. 7, 8 here. Those are not 8s. This is not 8, so this now must be an 8, so this is 7, this is 8. And the 44 is just there to solve this. So we already have 7, 10, 17, 25, 32. We need another 10, so those two will have to be 6s. That's 7, that's 6, that's 7, and that is 7. And this completes this solve, which was quite the adventure. And this stuff with the 5 here, with the 1s, with the 2s, that was really, really very well constructed. A very nice job by Nityant. And so, thanks for watching this video, and see you pretty soon on SudoKanard.